Hello folks, this is tutorial number 2 or video number 2 in a playlist which is called Kinematics and Motion Design App in 3D Experience. What we have here is a block. The dimension of the block is given 1 meter by 1 meter, which is accelerating down a track in a prescribed way. What we like to do is to create a kinematics model of this and plot the velocity, acceleration, and position of the block as a function of time. Now, the track, size of the track doesn't matter, but this is what I've taken because track is going to be stationary, it's not going to go anywhere. And the block, I'm assuming, is 1 meter by 1 meter, okay? Now, from elementary physics, we know that if the acceleration is 2 meters per second squared, you integrate it, you get the velocity. So integral of 2 is 2t meter per second. And if you integrate it again, assuming that it starts at the zero position with zero velocity, you get the position of the block as a function of time being parabolic, t squared. Okay? Now, when it comes to specifying this, I'm going to specify the velocity as a function of time, but not as a function, but as a graph, a linear graph, which starts at 0, 0, and let's say after 4 seconds, it goes to 8 meters per second. Okay, so basically, we're going to provide the data, 2 points on the data on the curve, which gives you that expression 2t. All right. Now, I want to point out that none of these tutorials that I'm making, in fact, nothing that I do in the entire YouTube channel, my YouTube channel, is necessarily the best way, the most efficient way, or a good way of doing it. But that's one way. Okay. So let me go here. We start with assembly design because this is an assembly of 2 pieces. Assembly design. Right there. And I make sure my units are changed so that I have SI units. So we go to preferences. Okay, for length, I want meters. For velocity, so let's say filter it in the descending order or sort it in descending order. Let's go and find velocity. Velocity. Velocity in meter per second, inch per second. I'm going to change it to meter per second. And acceleration is up there. Okay. So let me insert my first piece. Insert, right click, insert 3D part. And I'm going to call this thing, track. I'll make the track first. Track and track. All right. Very simple geometry. It's just a box basically. Double click on it. On that vertical plane, I will sketch something that's one. I'm going to put some dimensions here. The width of it, I'm going to make 1 meter. And the height of it, although it's irrelevant, I'll make it 0.25. 0.25 meter. And let's fit it. There we are. And exit. And pad it by 10 meter. Okay, good. So this is going to be my track. And while I'm at it, let me change the property so that the color looks, I don't know, did I make it yellow? I think, Should I make it yellow? Yeah, yellow. Okay, good. Now, all the way to the top, we want to insert our block. So right click, insert 3D part. We're going to call this thing the block. These are pretty elementary, but I want to do it in case you want to keep up with me instead of you making these parts and double click. On that same plane, I will sketch another uh, another box, another rectangle, dimension it. This is going to be 1, and this is also going to be 1. These dimensions don't matter because we're doing kinematics. But okay, so exit, and we pad it by 1 meter. So there we are, and I'm going to change the color of it to orange. Okay, good. So what I'm going to do is, now there are different ways of doing these things. You can create the joints by, 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 by doing it in the assembly design, or you can create joints later on after you go to the motion design application. But I'll do it like this. So first thing, we go all the way to the top. Notice that I didn't do anything about masses and things like that because I'm doing a kinematic problem. We will come back and worry about those things in other tutorials where forces and masses and things like that become critical. Now we go to, we're going to fix the track. Track is fixed, you can see that right there. And then I'm going to create a revolute joint, not a revolute, a prismatic joint between this block and that track. So here's a prismatic. And the different ways of making prismatic, I'm going to do edge and edge, plane and plane. So I'll do this one, really doesn't matter, this edge and that edge, this plane and that plane. And I don't need to control it, so I'm just going to delete that. It really doesn't matter. Edge and edge, plane and plane. And I say no. Okay, good. So let me make sure that my view is, let me see now, is what I want. Yep, there we are. Okay, let me save. It's all saved now. So what I'm going to do is go to the compass here and go to the application which says motion design. Okay, motion design. You click on it. These things pop up. So there's a couple of things you should realize. What it's trying to do is to create an analysis case. And it says if you have many mechanisms in your model, which one do you want? I have only a single mechanism, a prismatic joint, right? So I select it's a new mechanism and I say okay. Good. So here's the situation. Notice that it created this, it created that, and let me move these things out of the way. Okay. If you check this, first of all, on the global, it says gravity and there's a mechanism. And there is a gravity applied here, but we're not going to use it. So it really doesn't matter whether you keep that thing the way it is. You're not going to be using, we're not going to be doing a dynamic problem. Okay, so let's just leave it the way it is. And there are two bodies here, track and the block and the ground. Now I didn't do the ground, but it does it by itself. Okay. And there are two joints. There's a fixed joint, track, and there is the prismatic one between the block and the track. Okay, there we are. Now, what are these? First of all, if you close these, and you want to get it back. I already told you, for example, if you want to get the app back, you go to mechanism under tools, right here, app option. This thing comes back in the event you close it and you want to get it back. You may want to check this video one that I've mentioned this thing. And in the event that you want to get the other one back, the other one was, if you go to simulation tab and you click on the motion manager, the other one pops up. Okay, these are the two that are purposely closed, but there you are if you want to get it back. Good. Now, notice what happened here is I have to specify the velocity here. So you go to the mechanisms, see that mechanism tab, you scroll to the right, you get driver. Now driver is a misnomer. What it means is a command. In other words, you want to tell what actually is responsible for that thing to move. Is it the velocity? Is it specifying velocity? Is it specifying position, etc.? I'm going to click on the driver. Okay, this thing pops up. And then it says, what is a joint? Well, let's go find the joints that we created. It's the prismatic one right there. You see that? It's the prismatic joint that we created right there. You select it there. And then you want to give it essentially the form of that thing that you want to specify. You click on this, create a new function. This thing pops. You select this. You go to the data points. See that? Change the constant to data points. All right. And I don't want to specify the angle. I want to specify the velocity. Velocity right there. See that? I selected the data point from menu. And then I can select the velocity here. And then I can add two pieces of information to give you that velocity. First of all, when time is 0, see x is time. When time is 0, velocity is 0. Okay. When time is, for example, let's say we run it until 4 seconds. Okay. 4 seconds, the velocity is 8 meter per second. Now, how do we do that? There is an icon here. You see this? Append a row. So for 2 seconds, this is going to be 8. 8. Remember 2t. When t is 4, should be 4. When t is 4, this is going to be 8. So there it is. See that? Now this is the interpolation with a natural cubic spline or line. We can make it linear in this problem. When time is 0, velocity is 0. When time is 4, velocity is 8. So basically that replicates my function. My function was 2 times t. Velocity was 2 times t. Now we close it. Okay, so first of all, notice that here analysis case was created, motion analysis case was created. And in it, there is a dynamic step, but automatically created. I didn't do that. As soon as I created the motion analysis case, it did it for me. If you double click on this dynamic step 1, now I don't want to do dynamic step. I want to do a kinematic step. You click on this and expand this. It says, okay, give me the position, velocity, and acceleration instead of just instead of just doing the position computation. I want position, velocity, and acceleration. And how much time do you want it to expire? Not 5 seconds. That's the default. I'll make it 4 seconds. Duration of 4 seconds. And then you say okay. Now, if I click on this, by the way, notice that the 5 was changed to 4 here. If I click on this, it will show me basically what's going to happen. If I click on that, and that icon says preview animation, you click on it, it's going in the wrong direction. Okay, So one way to fix that, this is reset, by the way. Go back here to that function, go back to that function that you created. Notice that you created a function, data points, remember that? You created this, double click on it. So you go to, because this one in the other direction, I put a -8. Show me the plot. There. Say okay. Now we go back here and preview. There. That's good. Okay. All right. So reset. This is the reset. See that? Exit. Reset. Okay, good. Now we haven't run it yet. All we did was a preview here. So we go and run it. Now how do we go to run? We go to simulate, run analysis case. You click on it. The only thing that I haven't done is to specify a probe, because at the end, I want to plot some stuff. Okay, so for example, before I do that, let me go and create my probe. Go back to mechanism. See if I can find a probe here. The kinematic measurement. You click on it. This is the old probe in CATIA and in MSB and MSD. Okay, so select that corner point, for example. So we're going to plot the information about that, and then we say okay. All right. So now we go to simulation, run it, run. Wait until this thing finishes. Say okay, close. Now we go to results, results tab. Make sure that this is selected, because if you don't select this, it's going to come back and say, go select it. See that? Select this. Here's the animation. Here we are. And if you play it, it goes to after 4 seconds. This is where it's going to end up. And let me close that. If you want plot, click on the 2D plot. This thing pops up. Okay, what do we want to do? This is very confusing the way it's implemented as far as dialog box. Okay, so let's look at this. We can say, show me the stuff about the block. Show me, for example, the position as a function of time in the x direction. Show me the velocity as a function of time. Show me the acceleration as a function of time. So add plot. There we are. So look, get rid of this for a second. I don't want that. Now, notice that I have 3 curves here. The red one is the acceleration of the block in the x direction, and that value is 2. And if you wonder, you can click on this icon, cursor, value cursor. Notice that the red one, it says 2. The blue one is the linear velocity, so 0 here and 8 there. You can see that right there. And this one is the parabola, the t squared one, the t squared. Okay, see, t squared. When t is 4, you get 16. Now, anything that you don't want, you can either hide or you can delete it from here. You can delete it from here. Now, one other thing that I'm going to do is I'm going to say, okay, what if I wanted the time not to go to what was the value here? Not to go to 4, but to go 3.16. Is that what it was? Click on the wrong one right there. Double click on this. I don't want to go to 4. I want to go to 3.16. Okay. And then we say okay. And let me move this thing out of the way here. It goes all the way to 3.16, and now run it again. Go simulation, run it again, wait until this thing finish. And then, for example, let's look at the animation. There we are. This is select, go to results, select the kinematic step, and then say play. This goes all the way to 3.16, which means stops around here. Yeah. Okay. Good. So this is the first tutorial. Believe me, there is a learning experience here. And the reason that I want to do these simple problem is that if we can't do simple problem and interrogate them, it's going to be very difficult to take a full-blown assembly of different parts, etc., and try to find out what is going on. All right. Good luck.